G'day, this is just a quick follow-up to the previous video about that Hewlett-Packard UPS, which is actually a rebrand of a model made by a company called Eaton. Couldn't find much information on it, just a user manual, which doesn't go into the internals at all. In fact, I couldn't even get a definitive answer on how it operated. I originally thought that normally the AC coming in goes to the output sockets, and this business here only got invoked when the power failed, but I got the fairly strong impression, though I couldn't find anything that said it for sure, that this thing is always converting the incoming AC to a nice clean conditioned sine wave going to the outputs, so it can tolerate brownouts and disturbances on the incoming and still give you a nice output sine wave. So I believe that's how it works, but I wanted to understand it a little better, so I took all the big parts off here and reverse engineered this board and came up with this circuit. It's not what I was expecting. There's clearly a H-bridge here which has outputs going through these two smaller and big inductors to the load and neutral, and that goes to the outputs. And you can see that the bus positive comes from the incoming line through those rectifiers, but I keep looking for neutral also going through these diodes to form bus minus, and I can't see anything that doesn't. I've checked it lots of times. This is what's in there. Likewise for the battery, there's fairly convoluted path for the negative, which looks wrong going through those diodes. The positive can go through that relay there straight to bus positive. So I'm not at all clear on how this thing works, and asked a question on the EV blog forum, see if anyone else had any ideas. There's a couple of suggestions, all pretty vague. One thing that probably makes sense was that these two transistors and the big inductor, this brute, form some sort of a boost converter that takes the 120 volts of the battery up to 240 volts and takes whatever comes in on the bus. I'm not sure what voltage you'd get out of this because I can't see how it rectifies it, but some sort of boost converter to make sure there's enough voltage on the bus, and then this business forms a sine wave coming out. Can't see how the charging works. These two transistors have probably got something to do with it. Yeah, it's all a bit vague. So anyway, I got some nice parts out of it, like these brutes, and that took another brute, this thing, to unsolder them. Yeah, because this board has bloody Euro solder, lead free I'm pretty sure, so it's a mongrel to get off. But I've got some nice parts now, these guys, two of this one, pretty nice heatsink, and a bunch of IGBTs, and these nice current shunt sensors, Hall effect sensors, some capacitors and relays. These two capacitors are interesting. There's two of these, and this one's sitting here across the output, and this one's sitting here across the DC bus. And these are called bus link capacitors. I couldn't find any data on them, but I found a description of them. Look at the size of the terminals there. They're intended for very high ripple current. It's only 10 microfarads, but 600 volts, and also very low equivalent series resistance and equivalent series inductance. And they're used when, like for instance the one across there is probably to suppress large transients on the bus and protect the IGBTs. Well, that's one explanation for these things that I saw. But yeah, nice to have a couple of those for whatever I make with all these other parts. So that's all there is on this. Next up is that other transformerless one, which does look a bit more conventional. It's more complex inside, but it looks like it more understandable double stage converter, taking the AC mains, rectifying it to high voltage, sitting on a bunch of big capacitors, and then a conventional bridge like that to produce the output voltage. So pull that apart next, so if you're interested in seeing that, stay tuned. Catch you later.